Okay, so this is from the basic textbook that we used to use. So this is a different lesson. It says 12.7. 12 was the big geometry lesson, but we actually went far through a lot of the shapes already. So this is the last section, is the 12.7. And of course, we can do the chapter review as a little bit of a test to go back to the beginning and make sure we remember everything. So this one is only cones, cylinders, spheres. They kind of separated the formulas with the pi symbol in one lesson together. So the pictures didn't come out so good on the scan, but this is a skating rink. So we're going to take a look at this one. The key concept is the volume of a cone, cylinder, or sphere is the amount of measurable space inside the object. These objects are three-dimensional, meaning they have length, width, and height. So their units of measurement are cubed, such as cubed, inches cubed, feet cubed, or meters cubed. So sometimes, like in the other book, we also say cubic feet, cubic inches, cubic meters, which is a clue again, whether or not you're working with something that is a plane, flat shape, or if it's a solid or 3D shape. So this is reminding you, recall that the area of a circle depends on the circle's radius. The constant pi, which is approximately equal to 3.14, relates to the area of a circle to its radius. The formula for the area, or capital A, of a circle is A equals pi r squared. So this one we had, of course, with the two-dimensional shape. Now they're mentioning the skating rink. So area is measured in units of length squared. For example, if a circle's radius is measured in inches, the units of its area are inches squared, or inches with the tiny little 2. Imagine that a circular ice skating rink has a diameter of 20 meters. The area of the rink, or the total amount of space on its surface, is A equals pi r squared. Remember that the radius is 1/2 the diameter, or diameter divided by 2. So this one is saying A equals 3.14. And you can't really see that well, but if you look at the picture, what they're showing you across the line of the skating rink is that D equals 20 meters. So what they're saying is if you had this kind of a picture, you have to remember to cut the diameter in half and say that the radius is only 10. So this is where they're doing the 10 times 10, because they're saying radius squared, which is 100, which means you're just moving the decimal point from 3.14 to 314, because you're going to move the decimal point for every 0 in your number. So here we have 100, there's 2 zeros. You're going to move it from in between the 3 and the 1 to now it's at the end of the 4, making the number 314. So they're saying that ice skating rink has an area of approximately 314 square meters, because again, 3.14 is just an approximation. So that was the reminder about pi and area. Here we have some vocabulary, and I was looking for this vocabulary word yesterday, which was the frustum. We have apex is the same as the last textbook, and math is fun. Base, cone, cylinder, frustum, and sphere. So this is the cutoff cone that we were talking about if you have a cup or something like that. So now we're into volume, and this is just volume. So the reason why I've uploaded this chapter is because it just focuses on volume separately from the surface area and going back and forth, which can be a lot of formulas at once. So we're just going to take a look at volume today and then go back to looking at surface area and volume tomorrow. So here they're saying volume is, again, how much space something is taking up. That is 3D. So you're thinking of what could fill the space, or if it is a true solid, what it's made out of. So like if you're going to make something like we said yesterday, that is wooden blocks, or if you're making something that is made out of silver or plastic, it's not hollow. That's when you're talking about how the volume that's there. If something is hollow, then you're talking about filling it, like we did yesterday with the oatmeal container or a fish tank or a box or anything like that. So here they've got the volume of a cylinder, and what it's doing is the same as the other textbook. It's just saying that you have the pi r squared, and now you have height. So it's giving you the definition of a cylinder. A cylinder is a solid with two circular ends and one curved side. The formula for finding the volume of a cylinder is given by the following equation. V equals pi r squared h. The length r is the horizontal distance from the center of the cylinder to its curved edge. And these are the ones that we said you'll probably have that's creating the right angle because it's coming down from the center and going to the edge. So Math is Fun was showing a couple of other styles of cone and cylinder, but you will probably get the most straightforward one, which is the one that creates the right angle. So what they have as an example is a kitchen trash can. So it says, suppose your family buys a new kitchen trash can. The new can has a diameter of 20 inches and a height of 34 inches. You can use the formula V equals pi r squared h to find the can's volume. That is, you can find out how much space the trash can will occupy in your kitchen. So like we said yesterday, if you get anything with geometry, you always want to start with the formula because you just want to treat it like a regular equation after you understand what they're asking for. So is it perimeter? Is it area? Is it volume? Is it surface area? Once you make that decision, you're really just doing the algebra again. So they started with the volume formula, V equals pi r squared, and then h for the height.
Good, thank you. All right.
They said that the diameter, yes, since I just posted this one, most people haven't printed it, right? The diameter is 20 inches, so you want to cut that in half to work with the formula. So it helps when you write down the formula because then you can say V is the volume, pi is pi, 3.14, r is the radius, h is height. Those letters, especially being the first letter of the word, is helping you remember the purpose of the formula. This way, when you're like, oh, 20 inches, again, when the examples are saying, consider this graph, consider this picture, consider this shape, you want to actually do the considering so that when you look at the trash can, you can say, oh, I'm looking and I identify that the diameter is 20. Now, when you don't need the diameter, your mind should already say, I need the number 10, right? So it helps. This is why we're translating the formula so that you don't feel like you're starting from scratch every single time. You feel like you're more reading a sentence, that the volume of this trash can is going to be pi times the radius squared times the height. So they cut the radius in half, or they cut the diameter in half, which was 20, cut in half is now 10. So when you get down to the fourth line, you've got pi times 10 squared times 34, because they did all the replacing. They found the r was 10, the h is 34. So in a sentence like this one, it's just the order of operations. You should do the exponents first. Then you can multiply 3.14 times 100 times 34. So you've got 10,676 cubic inches. Now it's saying birthday candles is the new cylinder. A bakery owner sells a variety of birthday candles. His large candles measure 0.5 inches wide and 2.5 inches tall. What is the volume of each candle? So now you have the same formula that you have how wide the candle is 0.5. So now you have to cut the 0.5 in half. So what you see they have for the radius is 0.25 times 0.25, then times pi, which is 3.14, then times the height, which is 2.15. So they're saying the volume, and they've got the wavy equal signs to be about. The volume is about 0.49 inches cubed. So we're not doing surface area yet, but here is a quick problem. A food manufacturer packages cereal in cardboard cylinders. The cylinder measures 6 inches wide and 12 inches tall. What is the cylinder's volume? So take a second to figure this one out. So for this one, we're still at a cylinder. So we want to pick out the formula.
Wrong.
And what it said is
Ain't wrong. That's wrong.
that the cylinder measures 6 inches wide. So what does that mean, that the cylinder measures 6 inches wide?
That's the diameter?
That's the diameter. So these are just the different ways that they might actually be presenting the information that you want to say, okay, they measured from the middle, which would have been the center of the cylinder, and from edge to edge, like measuring the whole length is going to be the diameter. So because they're telling you that 6 is the diameter, what do you need for the formula?
The radius?
You need radius. So you have to cut that in half. So what you're really going to say is the volume is 3.14 times 3 squared, and the height was 12. So this is what you should think to yourself, that this is really translating to. You don't need the number 6. You need the number 3. So now you've got 3.14 times 9 times 12. So you should have the volume is about how much?
339, 12?
Yep.
339, 12.
And you, depending on what you use, and depending on also what it asks you to put it in, you might just stop at the 339 because we're saying about, and it depends. Are you using 3.14? Are you using the pi button on your calculator? Depending on what you use, you're going to get a little bit of a different answer, but it still should be straightforward with what you need to pick because you're going to be doing multiple choice the majority of the time. So now moving on to another one. This is volume of a cone. So we also looked at this one and we said, we're introducing a shape, but then the next shape that's coming after it is related in a way. So what we were talking about yesterday is similar to the triangle and a rectangle where you're saying, oh, triangle is half of a rectangle. So I understand that, let me see, go back to a piece of paper. What we said about the rectangle was that you have a rectangle and area equals length times the width. So what we said about a triangle is that it is half of a rectangle.
Let me.
So you're imagining the reason why this formula is 1/2 the base times the height is because of the shape of the formula. So once you're getting the information about all the shapes, you are thinking about how they relate to each other because that helps you memorize the formulas if it makes some type of sense, right? If you're saying, okay, I know where this is going, it helps it stay in my memory. So this is saying that the volume of a cone is 1/3 of a cylinder. So this is why now it's the same formula, pi r squared with height, but it's only 1/3 because it's coming to a point. So all of the rest of the cylinder is cut away. So this is saying that the base is the flat part and the apex is the point again, just like the pyramid that we saw in the other textbook. So you're gonna do this formula saying that volume of the cone is 1/3 pi r squared height. But you're also thinking that the cone is 1/3 of a cylinder in a way to help them stay connected. So this one has what we were talking about yesterday as like those water cooler cups. So it says, imagine there's a water cooler in the school's gym. The cooler comes with cone-shaped drinking cups. The cups are 10 centimeters high and have a maximum diameter of 7.5. What is the volume of one cup? So now this is where we said you're using your imagination. Sometimes it's going to be the cone that's in the street. Sometimes it's going to be like this, where you're taking the cone and kind of flipping it upside down and filling it like an ice cream cone or like a cup. So you have third pi r squared height, and they're saying that the maximum diameter is 7.5. So that's all the way up to the top. So that would be if you filled the cup all the way to the top with the maximum amount of water. So what they're saying is, of course, that's the diameter. When they're talking about how wide it is, you have to cut it in half, and that became the 3.75. So now they're saying 3.75 squared, 1/3 times 3.14 times 10. And it's about 147 cubic centimeters. Coming down a little bit more, I've got another example. The same bakery owner that sells birthday candles also sells conical party hats. So this is another example of a cone for children and adults. Adult party hats have a diameter of 7 inches and a height of 9 inches. What is the volume of an adult party hat? So now here they told you the word diameter, and you're coming back down to the 3.15 again. Once you cut the 7 in half, you get 3.15. So you're saying 3.5. 3.5 times 3.5 times 3.14 times 1/3 times 9. So now you have about 115 cubic inches. So now I'm just going to scroll back up to look at this margin, because this is where they're talking about the cone again. And it says you can add or subtract volumes of 3D shapes to determine the volume of more complex shapes. So this is what we were saying. This would be the most complex, is if you had to somehow take multiple shapes, or the idea of multiple shapes, and then create a new shape, which we're going to get to in the last section of the other textbook. So this one's saying, for example, consider a cone with a height, h, and they have a little subscript 1, and a radius with a subscript 1. If you cut off the top of the cone, the part you cut off is also a cone. It has a height of h with a subscript 2 and a radius with a subscript 2. So what this is just saying is, this was a larger cone, right? They're subtracting the smaller cone, and then that leaves you with what we were saying could have been like a bowl shape, or another kind of cup shape. But the shape that they're calling it is the frustum. So they have a way that you can figure this out would be to know the shape of a cone, then say, what did you cut off? And that would have to equal what's left over as a bowl. So this one says the original cone's height is 12 inches and the radius is 8 inches. The part of the original cone that was cut off, the height is 4 inches and the radius is 3 inches. In a notebook, use the formula for volume of a cone twice to determine the volume of the frustum described above. So let's just see if we can figure this one out. So what did you get for the volume of the original cone? So we've got that the height is 12 inches and the radius is
8 inches.
8 inches. So what you want to say is you're going to keep that number 8, right? And say 1/3 pi 8 squared 12.
One-third pi.
So what number did you get?
1/3 pi. 1/3 pi. Wait, hold on. 1/3 times
Wait a minute.
57.6.
Nope, I have a higher number than that.
Okay.
Anybody else have a number?
I think I know what I did. Okay.
I have the 301.44, but
Is it 230.4?
Let's see. So after you write down the formula,
Yeah, let me do it again. I gotta concentrate.
the radius is 8.
Uh-huh.
Yeah.
And the height is 12.
Okay, so 8 times 8.
I got 300,
64.
8. I have
So 64. Small. So let's see. 230. 230.4. Oh, I'm missing pi. Sugar. $7.23. Let me do it again. Wait not.
Now it just depends on what you're using. So I'm going to go to my calculator.
Times
768. I got 768.
723.45.
I say 64
Uh-huh.
times 12
Yes.
times pi,
Okay.
and then times 1/3. So now this is the same thing when we said we were doing percents and decimals. You can memorize 1/3 as a decimal. So what decimal did you put in?
0.30.
So now I would put in like 333.
Okay.
So that my number might come off a little bit, higher, just because it depends on what you're putting for a third and what you're putting for pi.
Okay.
So then I would say it's 803.
800.
Right. Okay, I was putting 0.3.
And that's close, right?
Yeah.
So again, like when you're doing it, you're gonna have multiple choice. But what we're saying is normally as a fraction is 33 1/3 or 33333. You kind of have that repeating 3 for a little while. If you just say any fraction that you don't know, you're gonna say 1 divided by 3, just reading from top to bottom. So you can see here it's got 0.33333333333, but I just stop after 3 of them, So if you don't know the fraction, you can always do division real quick and get I'm sorry, if you haven't memorized the fraction as a decimal point, you can just put the fraction into your calculator as division, because that's what the fraction bar represents. But when you do that, so you've got 803 as the first cone. And basically what it's saying is, you are going to subtract the second cone from the first cone, and that will leave you with this leftover shape. So now for the second cone, so we've got 803-ish for the first cone. For the second cone, we have a radius of 3
Okay.
and a height of 4. So you're gonna do the same thing, 1/3 times pi times 3 squared times 4.
$12.54.
I have 37.64. Did you multiply times the height?
No, I didn't put the height. I just did the decimal, the 333 pi times 3 times 4.
Well, you want to make sure you're gonna multiply in the order of operation style. So you can either use parentheses
Mhm.
or do it in an order that you've already done the 3 squared.
Try it again.
Because in the order of operations, you would do 3 squared first.
Okay.
So if you want the calculator to do the order of operations, you can put the parentheses, or you just say 3 times 3 is 9 and start with the 9 times 4 times pi times 1/3. And you can do that multiplication in any order after you do the squaring.
I got it. Okay. I got it. This.
So now this one you might say it could be 37 or 38. It depends on what they're saying, because again, we're rounding. So if we want to round up to 38, then we're going to say it's the 803 minus the 38. And this is about 765. So now this again would be the most complicated kind of question where you have to understand you're taking one shape from another shape. But this shape is a popular shape because it is kind of like what you might see at the same thing, like ice cream cups or ice cream bowls. This idea that if you flip this shape around, it would be coming to a point, but that part is cut off. So now you're thinking like we did yesterday with the soup cans or the oatmeal boxes or oatmeal cylinders, whatever shape they're describing in manufacturing, you're gonna have to figure out which of these formulas would work for that. So in this case, this would be if a cone had part of the cone cut off, if that makes sense. So now we've got one more think about math. It says a gym teacher orders a set of solid disc cones to create lanes on an outdoor field. Each cone stands 2.25 inches tall and its base has a diameter of 7.5 inches. What is the volume of one disc cone? So they're using that 7.5 as the diameter. And you know you need radius. So you have to cut the 7.5 in half.
Hmm.
175.
So you can translate this as the 333.
2, 2, 5.
Uh-oh. Something's not going well out there. But I'm not even gonna look. That sounds like a sibling fight, so I'm just.
Don't do it. Don't do
I'm not
it.
gonna go. My husband's out there, he'll handle it. So this is the translating of everything that's in the equation. You can translate the 1/3 as the 0.333. You can translate the pi symbol as the 3.14. You got the 7.5 that you're now saying is 3.75 squared. And then the height is the 2.25. So now if you're gonna do this in the calculator, you wanna have parentheses around everything so that the calculator can make sure it's doing the order of operation. If not, then you just wanna start with this part.
317.
So you can multiply in any order after you do the squaring. So you've got 3.75.
2.25.
And now you're saying times 2.25 times 3.14. So you're getting this approximately 33 cubic inches.
Yeah, not that 3308.
So now when you're doing these, you just got to make the choice of what order do you want to do it. So now I, if you can see in the calculator, I tend to start with the square and then go to the left, go to the right, and then I've memorized the 3.14 and the 0.3333, or however many threes you want to use. So what you want to do is just say you're going to do it the same way every time, because again, that's going to help with your memory, because you might only have one of these, right? So those two formulas, the cylinder and the cone, we actually already did. This was just to take a look at it with some other examples, like the cone for Jim and the birthday candle and the hat, and just to get a couple more examples of what a cone or a cylinder could be. Now this one is the new formula, and we're gonna stick with this same formula for sphere tomorrow. So we're just doing volume today. Tomorrow we'll do volume and surface area. So the sphere is just saying it's a round object like a ball or a globe. Every point on the sphere surface is the same distance to its center. So if you can imagine where it has the radius right now, what they're saying is that if you did from the middle to the top, from the middle to the other side, from the middle to the side, from the middle to the bottom, what it's saying is that every point on the sphere surface is the same distance to its center. That's what a perfect sphere is. And this is the formula for volume. This is now 4/3, or 4/3, times pi times the radius cubed. So now this is a different formula, but same thing. If you didn't know this one, 4 divided by 3 is now a whole 1, because we're remembering from fractions that 3 out of 3 is 1, and then you're back to 1/3. So you would translate 4/3 as 1.333. If you want to just memorize it as a decimal, which I think it's convenient to memorize it as a decimal because you're typing into a calculator. So if you memorize that one, it makes it easier. Or you just think about what it is. If somebody tells you 4/3, that's 1 1/3. And you already memorized 1/3 is 0.333. So this is saying you may have seen large spherical tanks standing on legs. Has anybody seen those driving down the highway?
Say that again?
Those large tanks that is like a sphere, and it has really elevated. So a lot of times they store water. Have you ever seen those?
Oh, yes, the one on the road that you see when you're driving on the highway.
Right, exactly.
Yes.
So now this is the example. You can't see this picture so well, but this is what they're talking about in the picture.
Yes.
So it's saying some are used to store water, others are used to store natural gas that has been changed from a gaseous to a liquid state. If a spherical natural gas tank has a radius of 8 meters, what is the volume? So now they're showing you the sphere. You kind of can't see the leg so well, but it's showing you that the radius is 8.
Misiru,
Yes?
you're still showing the whiteboard.
Oh, okay. Sorry about that.
Okay.
I have a million pages up. Can you see it now?
Yeah, we see it now.
Perfect. Thanks. So it's not the best picture, but since you've seen them before in real life, you can know what they're talking about. So when you do this formula, you're just translating again. The radius is the 8. So now you're saying 8 times 8 times 8, or 8 cubed. However you want to type that in the calculator is up to you. Then you're doing pi, which you memorized is 3.14. And then you're translating the 4/3 into 1.333. So for this, it's saying, what's the volume of this tank? It is about 2,144 cubic meters. The next example that they're giving is a globe, or like a 3D model of Earth. So what they say about Earth is, of course, it's not a perfect sphere, but a lot of times when we see it as a model or a globe, it is. So this one is Eartha, is a 3D scale model of Earth located in Yarmouth, Maine. It took engineers 2 years to construct the model, which measures 41.5 feet in diameter. What is Eartha's volume? So now this picture is terrible, but most of us have seen a model of Earth, even if it's just like the classroom globe. So same thing, they're saying it measures 41.5 feet in diameter. So what you want to say to yourself is that you're going to cut the diameter in half first to get the radius. So that turns into a radius of 20.75. And that's what you're going to put into the formula. So this textbook is breaking it down into more steps, which is why we're using this one. After you have this 4/3 pi times 20.75 cubed, they're putting that cubed into parentheses. Even if you just want to type it into the calculator and not use the cube or square button, it becomes 20.75 times 20.75 times 20.75. So you want to do this part first, either thinking of it like this, that you're going to do exponents first, for please excuse my dear Aunt Sally, or you're putting it in parentheses and typing it into the calculator 3 times now because it's the volume of a sphere. So this one you have to remember changes to radius cubed. Then you're just doing pi and then 1.33. So you get about 37,404 cubic feet. Questions about that one?
No.
All right, so then this will be our last one, and the next page is just a vocabulary page and a skill review where they're giving you a couple of other shapes like the soup can, the 8-ball, an apartment building that's shaped like a cylinder. So these will be the 5 that you do for today's assignment. And then tomorrow we'll pick up with surface area also by going into the other textbook. So this one says, in the same way that you can cut off the top of a cone to make a frustrum, you can subtract the volume of one cylinder from another to find the volume of a tube or a hollow cylinder. For example, say you have a tube 4 inches high with a diameter of 3 inches. The tube's walls are 1/2 inch thick. One way to calculate the tube's volume is to calculate the volume of 2 cylinders. Both cylinders are 4 inches tall, like the tube, but one has a diameter of 3 inches and the other has a diameter of 2 inches. So now this is where they're showing you this picture, right? Here's the one that they're talking about. And when it says the tube's walls are 1/2 inch thick, what it's showing you is that the wall is going to be measured on both sides. So this is where you say internally, right? So what might be hollow is really only 3 inches because you're going to say it's a 1/2 inch and a 1/2 inch. So really I'm subtracting a whole inch off of that, if that makes sense from the diagram, right? So it's saying one has a diameter of 3 inches, the other has a diameter of 2 inches. Subtract the lesser volume from the greater volume to find the volume of the tube. So this is, once you have 3 inches in diameter, so what you have is the outside measurement from edge to edge. Then you have the inside measurement that is taking account of how thick the wall is, right? And now you're seeing what would be the difference. So they've got the 4 inches minus the 2 inches equals the tube that you're talking about. Any questions about this one? It's kind of similar to what they already said. If you have to figure out this new shape, and this would, again, would be a more complicated version. So even though this is in the basic textbook, they're still presenting 2 more complicated ideas of looking at one shape as though it's 2, so that you can figure out the difference between
The outside and
the inside and the outside. Or like the frustrum, the difference between the whole thing and just part of the shape. And we'll have some practice with that in the irregular shapes. And I think a couple people did do that on study jams already as an introduction of just looking at a shape. So what we're also going to do just for fun is look around in your house today and see if you can find either of these. So a cone, frustrum, cylinder, or sphere, or a tube, like just to look around your house and see if you have any of these. And if you do have a ruler, tape measure, or something that you can measure, you can see if you can come up with the volume. So we're not doing surface area, we're just doing volume. But tomorrow you can say if you found any object in your house, because the other important thing about geometry is you want to look around and see that the whole world is made up of all of these shapes.
Okay.
So when you're looking at, you know, the clock or a box that comes in the mail or an envelope or your soup can or any of those things, you want to say that you're recognizing what the basic shapes are. And that's pretty much what we've gone through, are all basic shapes. There's a couple of advanced ones on Math is Fun, but these are probably the ones that you're going to get. And you never know, again, are you getting it just from 9th grade, 10th grade, 11th grade, or 12th grade? So this one is the one that I put up with today's date. If you want to reread anything or print it, the last couple of questions are pretty straightforward, but we're going to go over those tomorrow in the beginning of class. I think the vocabulary is super easy because we've already talked about that. But you've got one that's multiple choice for volume. Then you've got the other 4 you are calculating. So it's just got a line that you're looking at it and you're saying, I know how to do the volume of these descriptions. So you've got 2 pictures, and then you've got number 4, the apartment building in England, and number 5, the owners of a shopping mall in Germany want to have an ice cream cone sit on the corner. I think we've seen a lot of those. If you go to the shore, you know, or to a mall, you can see that people have added 3D figures to the outside of their buildings or, you know, off of the highway. So what we want to do is just be conscious of what those shapes are and what we could be talking about, if it's volume or if it's surface area. So this book is all volume. So you can try those, and we will go over the answers of those 5 tomorrow morning. And then we're back in the other textbook. We haven't gone over any of those yet, and that's a longer one, I think. Let me just pull that one up real quick. If you want to start that one, or if you already have, it's no problem. Some people haven't finished the quiz from Math is Fun, so that's why I uploaded this one, to give one more day with the formula. So this one that says 7.3, tomorrow,
We're gonna
We just have sphere left.
Okay.
So we're on page 239, where they're repeating the volume of a sphere, which is the 4/3 pi r cubed. And the only other thing is now the surface area of the sphere. So after we go through this example and example number 9, really we're just doing surface area. We now have these questions. So that probably won't take us that long tomorrow because there's really just one more formula. So probably it will be Wednesday and Thursday that we're doing this skill review, which is back to multiple choice and skill practice. The majority of them is multiple choice.
Are we gonna do the skill review as a homework or?
I think that we are going to do it as homework. So what we're
Okay.
going to say is tomorrow, we're really going to go over the answers from today's sheet, just to review. We will probably do like the vocabulary together and maybe 1 or 2 questions. But after that, we'll do it all as homework. So
Okay.
tomorrow's Wednesday. We might get up to like maybe number 3 by the end of class. And then I would probably say all the rest, because that's another like about 10 questions, would be for homework. And also, so like Thursday morning before class. So the idea would be that we'll still break off and say, how should we do it a couple of times for the thought behind it and the practice of step 1, step 2, step 3. But the majority of these are multiple choice. So if you can understand the breakdown of the question, that's going to be the real situation because this book is going between volume and surface area. You're going to have to decide that. So like just looking at this one, number 1 is the surface area of a box. So that's straightforward, right? Number 4, Lucinda wants to make a pair of earrings that are shaped like cylinders. So now she's making something, a solid, that's based on one of the shapes. Number 2, a traffic cone is a solid plastic, right? So you're thinking to yourself going back and forth, which is a little bit more challenging. Then number 5, a tent is in the shape of a pyramid. Even number 6, like we talked about tents yesterday, you want to make the canvas tent shown. The tent will be pitched on top of grass, so no canvas is needed for a floor. So this is where they're telling you canvas and making it is surface area, but you do not need the bottom because you're going to be on grass. So this is where you're saying to yourself, you might have to think an extra step or 2, depending on what they're describing in the word problems. So this one might be like our Thursday and Friday, just because it might take a little bit longer to work through multiple steps. And then what we would do after this is the task exercise book that we've already done for the other subjects. And that one probably would be about like 15 questions or so.
Okay.
So this is a little bit of a review, but it just gives you a chance to do sphere, cylinder, cone, and try these quick 5 problems. And I will see you tomorrow.
See you tomorrow.
If you have any questions, of course,
See you. Have a good day.
have a good day. Feel free to text me if you need to.
All right.
Okay.
Thank you.
All right.
All right. Thank
See you
you.
tomorrow.
See you tomorrow.
Guys, God bless you guys.
Bye.